In this video, we're going to look at the anatomy of the wave. That is, we're going to look at how we label each of the different parts of the wave. Now, there's several terms associated with waves that you're going to need to know. First of these is wavelength. The wavelength, like its name implies, is the length of the wave. It's given the symbol lambda and is measured in meters. So one way to measure the wavelength is to measure from the crest of one wave to the next crest on the wave, and that difference in distance is called the wavelength. Alternatively, you could measure from the trough to the trough. The amplitude of the wave is half of the height between the crest and the trough. So the amplitude is actually the maximum distance that the particles can be from their equilibrium position. So amplitude is generally given the symbol capital A and is also measured in meters. The period of a wave is given the symbol capital T. To measure the period of the wave, you'd measure, if you started your stopwatch when one crest passed you and then waited until the next crest passed you, you would have measured one period. So the period is how long it takes for one wavelength to move past you. The period is measured in seconds. The frequency of the wave is the inverse of the period, so it's how often these crests pass you. The units for the frequency are hertz or inverse second. So frequency is given the symbol F, and the frequency is equal to 1 over T. So let's do an example now.
So the question is, a wave travelling in the positive x direction is pictured below. Calculate the period, frequency, amplitude and wavelength if you measure that it takes 2 seconds from when one crest passes you until the next crest passes you. And here's the diagram showing the wave. Okay, so we know that the period is equal to 2 seconds, as it takes 2 seconds from when one crest passes you to when the next crest passes you. So the frequency is equal to 1 over the period, so that's 1 over 2, which is equal to 0.50 hertz. The wavelength is equal to the distance between the two crests, so that's 40 centimeters, which is 0.40 meters, and the amplitude is the displacement from equilibrium, so that's this 20 centimeters. So the amplitude's 20 centimeters, which is 0.20 meters.
Now, one important thing about a wave is its speed. The speed of a wave is just given by the frequency times the wavelength. Now, this isn't too hard to derive, as we know that speed is equal to distance over time. So the distance that a wave has to travel to be back to where it started from is 1 wavelength, and the time it takes to do so is 1 period. So we have that the speed is equal to 1 wavelength divided by 1 period. Now the inverse of a period is just the frequency. So this leads us to V is equal to F lambda. The velocity of the wave is equal to the wavelength times the frequency. Let's do an example now where we'll work out the speed of a wave.
So the question is, given the same wave as before with a period of 2 seconds, calculate the wave speed. So in order to calculate this, we'll need to use V is equal to F lambda. So we know that frequency is equal to the inverse of the period. So this is the wavelength over the period. The wavelength is the 40 centimeters, so 0.40 meters, and this is divided by 2.0. So we get 0.20 meters per second, or 20 centimeters per second.